AC circuit. So first of all, in order to find out the RMS value, we are required to find out the impedance of it. Might be some attraction and repulsion might be possible. So we have to check there whether it is by finding out the perpendicular distance, or you can use this formula directly to get a critical angle. If the angle of incidence at this phase is going to be more than this critical angle. Hello dear students, welcome to All in Overseas. I hope your preparation is going well for NEET 2023. So in this session, we are discussing 90 top most important questions for your examination. So we have divided it into 3 parts in physics, chemistry and biology. So I'll be taking the first part of physics, that is first 15 questions, and the subsequent portions will be discussed one by one. Let us come to the discussion of the first question. So this question is based on graphical representation of motion in a straight line or in any kind of motion. So in this question, it has been given that the distance traveled by a body moving along a straight line in time t is proportional to t to the power 3. The acceleration time graph for the motion of the body will be what? So as we can see that in this question it has been given that distance as a function of time. Now we have to differentiate it with respect to time to get the velocity as a function of time, and again we have to differentiate velocity as a function of with respect to time to find out the dependency of acceleration with respect to time. So we can write down here x is proportional to t to the power 3 as it has been given in the question. Now we can write down x is equal to any constant t to the power 3. Now in order to find out the velocity as a function of time, because we cannot directly reach to the acceleration, so v is equal to dx dt. This is d dt of k t to the power 3. This is equal to 3k t square. Now in the next step, we have to find out the acceleration. So what we have to do? We have to differentiate this with respect to time. So when we differentiate it with respect to time, we will be getting d dt of 3k t square. So here 3k being a constant, it will come out, and this one is 2t. So this is going to give us 6k t. If you will be looking at the expression, 6k is just a number, it is just a constant. Now coming to the proportionality of acceleration with respect to time, we can say that acceleration is directly proportional to time. That means it has a linear dependency. So when it is a linear dependency, that means when we are going to increase the time, the acceleration is going to increase. That means when t is equal to 0, the acceleration is equal to 0. When t is equal to 1, the acceleration is equal to 6k. When t equal to 2, the acceleration is equal to 12k. So the difference is going to be maintained in a linear manner. So which one is the correct graph? So this is the incorrect one. This is not a linear dependency graph. The second one is the correct answer, but we have to check that why the third and the fourth one is the incorrect answer. You know that this is not a linear dependency again, because this is decreasing with the increase of time, and here the acceleration is increasing with respect to time. Now coming to the fourth one, you can see that as the time is increasing, the acceleration is not getting changed, rather it is remaining constant. So this is also the incorrect one. So the correct option is option number 2. Moving to the next question. This question says that this is a conductor, and inside the conductor there is a charge q is placed over here, and we are required to find out the electric field at different regions. This is a very good question, which is the application of Gauss law as well. So in this question it is given that a point charge capital Q is placed at the center of the conducting spherical cell of inner radius small a and outer radius small b. The electric field due to the charge capital Q in 3 different regions, 1, 2 and 3, that we are required to find out and compare the answers. So I have drawn the diagram separately to find out the answer for this. So let me first write down the Gauss law. That how can we find out? You know that surface integral of, for a closed surface, E dot ds is equal to q enclosed divided by epsilon naught. Now what we have to do? So this is region number 1, this is region number 2, and this one is region number 3. So first of all, we have to draw the Gaussian surface for different regions. So for region number 1, I am going to draw a Gaussian surface over here. And you can see that how much amount of charge is going to be enclosed. You know that this is the electric field. This is a symmetric Gaussian surface, and we can see that at every point the electric field is in this direction and the ds vector is making an angle of 0 degree at every point. Only the magnitude of the electric field is remaining same, but the direction is getting changed. But at every place we can see that the electric field is making an angle of 0 degree with the ds vector or elemental area at that place. So how much charge is going to be enclosed inside? We can see that inside this Gaussian surface, the total amount of charge is capital Q. So that means we cannot say that the electric field is 0 inside the region 1. So we can clearly write down here that EI is not equal to 0 at this point in the region number 1, because the Q enclosed is not equal to 0. Now this is a very good question, because by using this we can find out the induced charges as well. But we know that inside the mid of the conductor, inside the region inside the conductor, the net electric field should be equal to 0. No electric field lines should be present there. So as a result, we know that some amount of charges are going to be induced inside it, which is nothing but its magnitude will be equal to minus q, so that the fluxes that are coming out of this plus q should not pass into the conductor. So that's why this is the amount of induced charge that should be present. Now we are required to find out the electric field in region number 2. So what we have to do? We have to draw a Gaussian surface enclosing the charges plus q and minus q in region number 2. So here is the Gaussian surface that we have drawn over here. And here also we can see that if I can write it as E in region number 2, and this is the ds vector. In similar way, but we will be checking that whether the charge enclosed inside this Gaussian surface is equal to 0 or not equal to 0. We can say here this is plus q and the induced charge is equal to minus q. So in this region, the net charge enclosed in the second region is equal to 0. If this q enclosed, this expression is equal to 0, so definitely the electric field will be equal to 0. So we get the second part of it is equal to 0. Now coming to the third part. So as we know that initially the conductor was neutral in nature and minus q was induced here. So the total charge of the conductor is equal to 0. So if you say that x is the total amount of charge which is going to be induced in the outermost region, so what should be the value of it? We know that minus q plus x should be equal to 0. So x must be equal to plus q. So this is the induced charge that is just present outside the conductor. So this induction of the charges has taken place because of the presence of this plus q that is placed at the center of this conductor. Well, so let us draw another region just outside it. The Gaussian surface here in this region will be this one. If I say that this is the electric field just outside it, here also you can see that the ds vector is just along the direction of it. So if we wish to find out that how much charge is going to be enclosed inside this Gaussian surface, we know that the total charge enclosed inside the third Gaussian surface will be equal to plus q is at the center, minus q is the induced one, and plus q is also the induced one, which is going to give us a result that is equal to plus q. So it also says that the charge enclosed inside this Gaussian surface is a non-zero value, which say that the electric field at the third part is not equal to 0. Now we got the value of all the three electric field for all the three regions. Let's come and compare the result. So look at these options. So the first option says that E1 is equal to 0. Definitely it is not going to be the correct one. So we are going to remove these options. So option elimination is also very important. So we can simply eliminate option number 1 and option number 3, because we already know that E1 is not equal to 0 because the charge is kept inside this conductor, and E1 is not equal to 0 and E3 is also not equal to 0. So fourth option is the correct one and the second one is an incorrect option. And we got the electric fields for all the three regions in this case. Shown in the figure, a current of 2 ampere is flowing in an equilateral triangle of side 4√3 centimeter. The magnetic field at the centroid of the triangle we are required to find out. We can analyze this question as 3 current carrying conductor of finite length. The length of the conductors are 4√3 are aligned in such a way that they are going to form an equilateral triangle, and we are required to find out the net magnetic field due to all these current carrying conductor at the point O. So to analyze this question, we have drawn the diagram in a separate set. So you can see here, this is the diagram. So it has been given that the each side of is 4√3 centimeter, and you know that being it is an equilateral triangle, so these angles are going to be 30 degree because this whole angle is going to be 60 degree each. So this is 30 and this one is 30 degree. So if I am going to draw up a perpendicular at this point, let the length of this perpendicular is d and this angle is 60 degree. You know that for a one single current carrying conductor of finite length L, so at a perpendicular distance r, the magnetic field, you know that if this is a current carrying conductor of finite length L and at a perpendicular distance r, if this angle is theta 1 and this is theta 2, at the point P we do find out the magnetic field as mu naught I divided by 4 pi r time of sine theta 1 plus sine theta 2. So we can clearly see here that, so here the theta 1 and theta 2 are equal, that is 60 degree and 60 degree. Now we have to find out this d, which is the perpendicular distance of the point O from this current carrying conductor, and due to symmetry we can understand this as each current carrying wire is having a perpendicular distance of d from the center O. Right, so in order to find this, so we can analyze this as this is a right angle triangle, and for this right angle triangle we are going to take it as this is the this length is equal to 2√3 centimeter. So what we can write, you know that perpendicular by base is equal to tan theta. So we can write here d divided by 2√3 is equal to tan 30 degree. Because this is the perpendicular, we are taking this as the base. So this is the 30 degree angle, and you know tan 30 degree is equal to 1 by √3. So this √3 and this √3 are getting cancelled out. So we are getting the value of d is equal to 2 centimeter. Now if you know the value of this perpendicular distance, we can find out the magnetic field due to a single current carrying wire here. So I am writing down the magnetic field due to wire number 1 is equal to mu naught is 4 pi into 10 to the power minus 7, and we are just plugging the values that has been given in the question. The current that is getting carried in the wire is equal to 2 ampere divided by 4 pi, and we just calculated the value of perpendicular distance small r or small d is equal to 2 centimeter. Do not forget to convert it into meter. So 2 into 10 to the power minus 2 meter multiplied with sine theta 1 plus sine theta 2. You know that theta 1 is equal to theta 2, that is equal to 60 degree, and sine 60 is equal to √3 by 2. So we can directly write here 2 into root 3 upon 2. So 2 and 2 are getting cancelled. Then 4 pi and 4 pi, 2 and 2, they all are getting cancelled. So what we are getting here, it is root 3 time of 10 to the power minus 5 Tesla. But this is not the answer to our question. This is the magnetic field due to only one current carrying wire, and we are required to find out the net magnetic field. So for that, we have to write down the total magnetic field is equal to 3 times of B1, that is 3 root 3 into 10 to the power minus 5 Tesla, which is the correct answer to our question. Let us match it with the options that has been given. This is given in option number 4 because all other options are incorrect here. So this is the correct answer to the question. This question can be solved in another way by using a formula directly, and this formula can be replicated to other regular polygons as well. So what is that formula? You have to remember that to solve the question very quickly in the examination. So this is the formula that you can directly use to find out the magnetic field at the center of any regular polygon. If I am talking about this equilateral triangle, so here the number of sides are n and each angle contained by the sides are going to be 60 degree. You can use it for a square, you can use it for a hexagon, you can use it for a regular pentagon, right? So you can use this formula, you know, mu naught is equal to 4 pi into 10 to the power minus 7. N is the number of sides. So in this case, the number of sides are equal to 3. Sine multiplied with current. Current is 2 ampere. Sine pi by n, pi is 180 degree divided by the number of sides, that is 3, multiplied with tan 180 divided by 3 divided by pi time of the length of each side. As we know that the length of each side has been given here as 4 root 3 centimeter. Do not forget to convert it from centimeter into meter. So this is 4 root 3 time of 10 to the power minus 2 meter. As we know that all other values has been given in SI unit. So we'll be getting the answer in Tesla. The unit is going to be Tesla. So as the next step, we are going to extend this. You know, sine 180 by 3 is sine 60, which is going to give us an answer is equal to root 3 by 2. Tan 180 by 3 is tan 60, that is root 3. Now let us write it down. It is going to be this 4 pi and this 4 pi is getting cancelled. Then again this root 3 and this root 3 is again going to be getting cancelled. So we are going to get here 6 into 10 to the power minus 7 into root 3 divided by 2 into 10 to the power minus 2. Look at here, it is coming as 3 root 3 into 10 to the power minus 5 Tesla. This is the same answer we got in the previous case. So we can solve this question in two ways, either by using the general method by finding out the perpendicular distance, or you can use this formula directly to get the answer. So in this question, it has been given that there is a circuit and we are required to find out the equivalent resistance between A and B. So you can expect such type of question in the examination. So how exactly not the same question, but the method is going to help you to find out the equivalent resistance of a given circuit. So in the next set, I have drawn the circuit and we can solve it by reconstructing the diagram to find out the equivalent resistance. Well, so in this question, you can see that the first method is to name all the ends of all the resistances. So you can see here this point is A. So all these points are of equal potential. So this point has got the same name, that is A, and this is A. This one is B and this is B. And you can see clearly here this 1.5 ohm and this 0.5 ohm are in series connection. So which is going to give us a result that is equal to 2 ohm. Similarly, looking at this 1 ohm and this 1 ohm are in series, so they will also give us 2 ohm. What about the other? So let us name it as point number M. So now we can see that the whole circuit, each and every resistance has been named that each side of the resistances has been named. So we are going to put the 2 points which are across which the resistance has to be found out. This is A, B, and this one is M. Now let us move to each resistance and connect them in the new circuit. Look at this 2 ohm. One end of 2 ohm is connected to A and the other end is connected to B. So I am going to connect it in this manner. This is 2 ohm. It has been taken and connected. Now look at this 12 ohm. One end is connected to A and the other one is connected to B. So I'll be taking it like this. This is 12 ohm. The next one is 8 ohm. One end of 8 ohm is connected to A and the other end is connected to M. So this is 8 ohm. Look at 4 ohm. 4 ohm has one end is at B and the other one is at M. So we are going to connect it in this manner. This is 4 ohm. M and B. One end is M and the other one is B, and the resistance which is connected here is 6 ohm. So we are going to write here is 6 ohm, and we can clearly see that the 6 ohm is in parallel with 4 ohm. For 2 ohm, one end is connected to M and the other end is connected to A. So we can write here this is 2 ohm. Which one is left here? The other one which is left here is 6 ohm. Anything else? Yes, this 2 ohm is also left, and we can clearly see that this 6 ohm and this 2 ohm are one end are joined at point A and the other end is joined at point B. So we can write here this is 12 and this one is 6. And I'm just going to connect this here so that the diagram should not look clumsy. So this one is 6 ohm, 12 ohm, all are done, and this is 12, 6 and 2. There are two ohms are connected here. You know that these two are in parallel with each other, can directly give us a result that is equal to 1 ohm. These two are in parallel with each other and they will give us 2 into 8 divided by 10, that is equal to 8 by 5 ohm. Similarly, these two are in parallel with each other, which will give us 6 into 4 divided by 10, that is equal to, I am intentionally keeping it as it so that it's going to help us for the calculation, right. So 12 and 6 are in parallel. So 12 and 6 are in parallel is going to give us 12 into 6 divided by 18, that is equal to 4 ohm. Now reconstruct the circuit once again. If we'll reconstruct the circuit, then you can see here this point is A, this point is B. Now A and B, this is 1 ohm. 8 by 5 is in series with 12 by 5. 8 by 5 is in series with 12 by 5 will give us 8 by 5 plus 12 by 5 is equal to 20 by 5 is equal to 4 ohm. So which can directly be connected across them. This is 4 ohm. So the last but not the least, this is 4 ohm, which is again going to be connected in parallel with this. Well, again all these three resistances are in parallel with each other. 4 and 4 are in parallel, which is going to give us a result directly that is equal to 2 ohm, and this 2 ohm is in parallel with 1 ohm. So if you wish to find out the equivalent resistance between A and B, then it is 1 into 2 divided by 1 plus 2, which is equal to 2 by 3 ohm. This is the answer to our question. Let us check with the options which one is the correct one. So the option number 1 is the correct answer to the question and the others are the incorrect one. So in this question it has been given that an electron accelerated through a potential difference V1 has a de Broglie wavelength of lambda. When the potential is changed to V2, its de Broglie wavelength has been increased by 50%, and we are required to find out the value of V1 by V2. That means we are required to find out the ratio of electric potentials through which this electron was accelerated. So for that, we should know that what is the relationship between the kinetic energy possessed by an electron because of the application of electric potential V and how it is related to the momentum of those electrons. And what are the formulas that we need to remember? We need to use to tackle such kind of questions. You know that the kinetic energy is nothing but it is equal to P square upon 2m, and this kinetic energy is possessed by an electron due to the application of electric potential. So this electric potential is, let it be capital B, and what is the relationship between this momentum of an electron with the wavelength? You know that this momentum is nothing, it is h upon lambda. And you know that h is nothing but it is Planck's constant, and this is a constant again, and we are equal to find out the comparison of these two. So we can write here that P square divided by 2m, that means h square divided by 2m square, 2m lambda square is equal to E V1. You know this is constant, mass is going to remain constant, and this is lambda 1 square. This is equation number 1, and for equation number 2 we can write h square divided by 2m lambda 2 square is equal to E V2. This is equation number 2, and let us divide both of it. We can get EV1 divided by EV2 is equal to h square divided by 2m lambda 1 square time of h square into 2m lambda 2 whole square. So being these are constant and equal, they will be taken out, and lambda 2 square divided by lambda 1 square. And what has been given to us in the question? You know that we are required to find out the ratio of these two, and lambda 2 is 50% more than lambda 1, which is 1.5 lambda 1 square divided by lambda 1 square, which is nothing but it is 1.5 whole square, because lambda 1 square and lambda 1 square is getting cancelled, and you know that 1.5 can be written as 15 by 10, so 15 square by 100. So we can easily write down it is 15 into 15 divided by 10 into 10. This is just to avoid the mistakes and do the question very carefully. So these are very easy, so we should not do any mistakes. So the answer is 9 by 4, and 9 by 4 is the ratio of the electric potential through which this electron has been accelerated, so that the de Broglie's wavelength has been changed in such a manner. So let us check the options. So the answer is option number 2, and the other options are incorrect. So in this question, it has been given that in the given circuit, RMS value of current through the resistor R is how much? This is a series AC circuit. So first of all, in order to find out the RMS value, we are required to find out the impedance of the whole circuit. So how to find out the impedance? In such questions, it might be possible that you won't be given the value of XL directly, or if it has not been given, so you can calculate this as omega time of L, and inductance will be given to you. And XC can also be calculated as 1 by omega C, but we are lucky enough that these values has been given to us. So let us find out the impedance. So for the impedance, we know that it can be calculated as R square plus XL minus XC whole square, whichever is going to be greater. So here R square is 100 square plus XL minus XC, that is 200 minus 100 whole square. So we can write here as 100 square plus 100 square, which is nothing but it is 100 root 2 ohm. And you know that the current is going to remain same for all. So that's why we are required to find out the IRMS, which can directly be calculated as IRMS is equal to VRMS divided by the impedance of the circuit, and the VRMS has been given as 200 root 2 divided by the impedance that has been calculated here is 100 root 2. This and these are getting cancelled. So finally we are getting the answer as 2 ampere, which is the correct answer to our question, and you can see that it is given in option number 1. In this question, it is given that a thin prism, this word is very important, thin prism P1 with an angle of 6 degree and made from glass of refractive index 1.54 is combined with another thin prism P2 of refractive index 1.72 to produce a dispersion without average deviation. We are required to find out the angle of prism P2 will be what? You know that the angle of deviation for small angle prism can be calculated as delta is equal to mu relative minus 1 time of angle of prism. So when such type of situation does take place, such type of situation does take place when we are going to combine the prisms in this manner, so that the net deviation is going to be equal to 0. Net should be equal to 0. That means we can say that the deviation by the first prism plus the deviation by the second prism should be equal to 0. Well, so this one is A1 and this is A2, and we are required to find out the value of A2 now. So we can write here mu1 minus 1 A1 plus mu2 minus 1 A2 is equal to 0. So in the next step, we can write here mu1 minus 1 time of A1 is equal to minus of A2 time of mu2 minus 1. What is the value? What is the meaning of this mu1? That means it is the refractive index of the prism with respect to its surrounding, and we know that in the surrounding we have air. Well, so here we are going to take these values and write it down. So for mu1 it has been given as 1.54 minus 1, and the angle of the prism is 6 degree. This negative sign implies that it is inverted. So here it is minus A2 we are required to find out. This is 1.72 minus 1. So that implies 0.54 into 6 degree. I am just writing it down and not simplifying it because it will help you to do the calculation without any mistake. So this is minus 0.72 time of A2. This is A2 will be equal to minus of 0.54 into 6 degree divided by 0.72. Well, now you can see here the decimal points for these two are equal, so you can treat it as 54 and 72. So I am just treating it as 54, that is 18 into 3 is 54 and 18 into 4 is 72. So this is 18 degree. I am just finding out the value. So that's why we can write down 18 divided by 4. 18 degree divided by 4 is around 4.5 degree, because all other options can be directly removed from here. So this is coming as 4.5 degree. This is the angle of the second prism, and this is the correct answer to our question, and it is given in option number 2. In this question, it has been given that two Polaroid A and B are placed in such a way that path axes of Polaroids are perpendicular to each other. Now another Polaroid C is placed between A and B, bisecting the angle between them. If the intensity of unpolarized light is I0, then intensity of transmitted light after passing through the Polaroid B will be what? So first of all, we have to draw the Polaroids and see that how they are aligned and can find out the answer. This is our Polaroid number 1. This is A. This axis is perpendicular to the axis of B. That means B is placed like this. This is our B. This is Polaroid number B, and C is placed between A and B in such a way that it is bisecting the angle between them. That means this is the position of C. Unpolarized light is having an intensity of I0. So here we can write IA is nothing but it is I0 by 2. We know this, that after this it should be I0 by 2. And how much angle it is making here? It is making an angle of 45 degree as it is bisecting the angle. So if you wish to find out the value of IC, then it should be equal to IA cos square theta between Polaroid A and Polaroid C is 45 degree. So I can write it as 45 degree. So this is I0 by 2. Cos 45 is 1 by root 2. Square of 1 by root 2 is 1 by 2. So this is going to give us I naught upon 4, but this is IC. But our question asks us to find out the intensity transmitted light after passing through the Polaroid. B will be how much? So this is IC. Now we will be finding out IB. So for that we have to check that how much is the angle between B and C. So here you can see that the angle is again 45 degree. So in order to find out IB, we can write here IC cos square 45 degree. So IC is I naught upon 4 into again 1 by 2. So it is I naught upon 8. This is the answer to our question. It is given in option number 1. In this question, which of the following correctly represents the variation of electric potential V of a charged spherical conductor of radius capital R with radial distance small r from the center we are required to find out? So this question is very easy and this can be asked in two ways. One is for conducting sphere and the other one is for non-conducting sphere. So in this question you have been asked that in order to find out the variation of potential in a conducting sphere. You know that for a conducting sphere, the charges are going to reside at the outer surface of the conducting sphere. So the electric field, they ensure that in an electrostatic condition, the electric field inside the conductor at every point is becoming 0, keeping the potential throughout the conductor equal. So if I am going to draw a conductor here and we are going to give it a total charge of capital Q, having a total radius of capital R, and we are required to find out the variation of the potential for these points. So inside the conductor from the center to the surface, we know that the potential is constant from this point to this, and that value is K capital Q, and K is electrostatic constant divided by R. And just outside it, how it does it vary? Outside it does vary as K Q, and this is constant actually, and this is KQ divided by small r, while the small r is the distance of any point outside the surface from the center. So you can plot the graph in such a manner. This graph is not correct because here it has been given that from here to here it is a linear variation. This graph says that from the center to the surface the electric potential is increasing linearly. So this is an incorrect one. Coming to the second graph, it says that the electric potential is 0, which is very, very important. The electric potential is not at all 0. Inside it, it is constant, but the electric field is equal to 0. So this is again an incorrect graph. Fourth one is clearly incorrect one. And the third one is the correct one. You can see that it is remaining constant. This value is constant till the surface, and outside it is inversely proportional to R. So the correct option to this question is option number 3. You have to be very careful that whether the question has been asked to you for a conducting sphere or for a non-conducting sphere. For a non-conducting sphere, this result is not going to be valid. In this question, it has been given that a bar magnet with a magnetic moment 5 ampere meter square is placed in parallel position relative to a magnetic field of 0.4 Tesla. This is a uniform magnetic field. There is no variation. Let's take an example. This is a magnetic field and which is having a magnitude of 0.4 Tesla. And the bar magnet has been placed in such a manner which is having a magnetic moment M is equal to 5 AM square. And we are required to find out the amount of work done in turning the magnet from parallel to anti-parallel position relative to the field direction. You just want to reverse this magnet in this manner. So how much amount of work is needed to be done? You know that whenever a bar magnet is placed in a magnetic field, it stores potential energy. And if you wish to rotate it, you have to do the work, and that work done is nothing. It is equal to the change in the potential energy stored. So we can directly write it down. Work done is equal to M time of B into cos theta initial minus cos theta final. There are many ways, but you can directly use this to find out the answer quickly. M is 5 and magnetic field is 0.4. I am not using the units here because all these units has been given in SI unit. If it is not given, you have to convert it into SI unit to get the answer. Well, so this is cos theta 1, initial angle. So with this, the initial angle is equal to 0 degree, and if you want to move it in this direction, so theta final is equal to 180 degree. So I can write cos 0 degree minus cos 180 degree. Well, this is 5 into 0.4, which is 2, and cos 0 is 1 minus cos 180 is minus 1. So very carefully we have to write it down. So 2 into 2, that is equal to 4 joule. 4 joule is the answer to this question, and this can also be remembered as a standard result. If you want to completely tilt it in anti-parallel direction, you can directly use the result as 2 times of MB. And this question could be asked to you in several manners, like to turning it into 90 degree and so on, or any other angles. In this question, it has been given that a capacitor capital C is fully charged with a voltage V0. After disconnecting the voltage source, it is connected in parallel with another uncharged capacitor of capacitance C by 2. The energy loss in the process after the charge is distributed between the two capacitors is how much? Let us understand this. It has been given that we have a capacitor and we are going to connect it to a battery having a potential of V0. When it is going to be connected to it, it is going to be fully charged and it's going to store some amount of charge in it. So when it was connected to a voltage source of V0, so the charge that has been stored in this capacitor is CB0. And now this has been disconnected from the battery and we are going to connect this with an uncharged capacitor. So this capacitor is charged now, which is containing a total charge of CV0, but the second one, which is not containing any charge, is having a total charge of 0, as it is an uncharged one. So it has got a capacitance of C by 2. Now they are parallelly connected to each other. Now when such type of connection is going to take place, the charge will start to redistribute between the capacitors. And you know that as these two capacitors are connected in parallel to each other, the potential difference is going to remain same across them. So the charge has to be distributed in such a manner that the potential difference will be common for both of them. So let the final charge on this is plus Q1 and on this it is going to be plus Q2, and the final potential difference is going to be Vc. That is the common potential. But the total charge Q1 plus Q2 should be equal to the summation of the charges that has been given to the system initially. So we can say that the total charge is not going to be changed, that is equal to CV0. This CV0 has to be distributed between these two, but not equally again. Why it is not going to be equally distributed between them? Because the capacitance are going to be different for them. Well, so we can write down the Vc is equal to Q total divided by C equivalent. Q total we already know the value, this is CV0, and what about the C equivalent? We can write down C equivalent is equal to C plus C by 2 is equal to 3C by 2. So I can write down here it is 3C and 2 will go up, C and C are getting cancelled, so this is 2V0 upon 3. But this is the halfway. We are only able to find out the common potential difference between the two capacitors. Now we are required to find out how much is the energy loss. This question can be extended to ask you to find out the amount of charge that is going to be stored in the capacitors. So I am covering all the aspects of this question. So this is the common potential. Let us find out that if we are asked to find out the value of Q1, that is the final charge on the first capacitor. So this is going to be CVC. C and Vc we have just calculated it as 2V0 upon 3. So this is 2V0 upon 3. And similarly, if you are asked to find out the final charge on the second one, then it is C by 2 capacitance of the second capacitor, time of the common potential. So this is C V0 upon 3. So if the question could be asked to you that how much is the charges are on both the capacitor. So the first one will have a charge of 2 CV naught by 3. The second one will get a charge of CV naught by 3. The one which is having more capacitance is going to get to store more amount of charge. Now let us find out that what will be the change in the energy in the process. So initially we can find out the E initial is equal to half C V naught square, because, and you know that the second one was not containing any charge, it was not connected to any power supply, so that's why it is not containing any energy. So the total amount of energy that is going to be stored in the first capacitor is half C V naught square. Coming to the second one, now they both are going to store the energy. We can write it as half C equivalent time of the square of the common potential. You have already calculated it as half, and C equivalent is 3C upon 2, and Vc square is 2V naught by 3 whole square, which is going to be written as, this is 3C by 4 into 4V naught square divided by 9, which is equal to C V naught square divided by 3. So this is the final amount of energy stored, and this is the initial amount of energy stored. We can say that clearly the numerator of the expression is same for both, but the denominators are going to be different, and it is clearly seen that this energy is more than the final amount of energy, and we are required to find out the difference of the energy of this system. So to find out the difference, we can clearly write down E final minus E initial. So this is CV naught square upon 2. We are just finding out the magnitude of it, because this is more than that, minus CV naught square by 3, and we can write it as 6, and this is 3 CV naught square minus 2 CV naught square is equal to CV naught square divided by 6. So this is the amount of energy that has been lost. So we are required to find out that change, and let's check the answer, and you can clearly see that this is option number 4, which is the energy loss in the process during the redistribution of the charges between the capacitors. In this question, it has been given that a rigid square loop of side A carrying a current I2 is lying on a horizontal surface near a long current I1 carrying wire in the same plane as shown in the figure. The net force on the loop due to the wear will be how much we are required to find out. You can see that here it is a square loop, and it is kept nearer to a current carrying wear, and it is also carrying current. So because of both of them are going to create magnetic field on each other, so there will be, it might be some attraction and repulsion might be possible. So we have to check there whether it is going to be an attractive force or repulsive force, and if it is attraction or repulsion, then how much is the net force is going to be exerted by this wire on the loop. So for that we have drawn the diagram again here, and here in this case you know that due to this wire a magnetic field that is into the plane is going to be created in the region here, but this magnetic field is not going to be uniform, rather it is going to be a non-uniform magnetic field because of the different points that has been present in this direction. So we can see here, so all these regions are going to experience the same amount of magnetic field, and this is into the plane. So every part of this current carrying wire is going to receive equal amount or experience equal amount of magnetic field due to this wire. And you know that due to symmetry, this and this is not going to experience any net force, because the force that is going to be experienced by this part of the wire will be nullified by the force that is going to be experienced by below part of the wire. So this is into the plane, and here also it is going to experience the same magnetic field, it is also into the plane, but the difference is that magnitude of B1 is definitely more than the magnitude of B2 because of its location. You know that this is an infinitely long current carrying wire, so the magnetic field that is going to be produced at this point can be written as mu naught I1 divided by 2 pi and the perpendicular distance is A here. And for B2, the magnetic field is mu naught I1 divided by 2 pi A plus A, because each side is A, so we can write it as 2A. Now, we can treat these as two parallel conductors which are carrying currents in opposite direction, and if we know that when two parallel current carrying conductors are present, they are going to attract or repel each other because of, and it depends on the nature or the direction of the current which is flowing in the wires. So, in the first case, if we will be talking about these two ends, so here the direction of the currents are going to be opposite to each other, so they are going to repel each other. So, I can write down, this is a repelling force and this force is F1, and this one is going to experience an attractive force. But you can see the size of the arrow that I have been given here, because the magnetic field at this point is more and the magnetic field for this part is less, and the amount of current and the length of this current carrying wire are equal. So, definitely you know that for this the force is equal to Bi time of L, we have already studied. So, we can write down that, I am going to write it as x and y, and this is m and n. We are writing down the force, magnitude of the force F1 is equal to how much it is, mu naught I1 I2 divided by 2 pi A, and this expression is again very important because this is the force per unit length, but we are required to find it out for this whole length. So, you have to multiply it with A. So, this is mu naught I1 I2 divided by 2 pi, but this force is in the rightward direction because this is a repulsive force. Similarly, for F2 we can write down, this is mu naught I1 I2 divided by 2 pi, and the distance we have already calculated it as 2A, but the length of this wire is again A. So, we can write here it as mu naught I1 I2 divided by 4 pi, but the direction is in this direction. You can clearly say that this one is more and this is less and this one is more. So, definitely F1's magnitude is more than the magnitude of F2, and F1 is a repulsive one. So, definitely the net force is going to be a repulsive one. Now, we are required to find out the magnitude of that force. So, F net is equal to magnitude of F1, because this is more, minus the magnitude of F2. This is mu naught I1 I2 divided by 2 pi minus mu naught I1 I2 divided by 4 pi, and we can clearly see that you can take this as LCM. So, this is going to be 4 pi and this is mu naught I1 I2 Newton, if all other things has been given, or we can simply say that it is an unit. Now, this is the expression for the net force, and what should be it? It should be repulsive or attractive. The nearest wire is carrying a current which is in opposite to the direction of I1. So, that is why the force is going to be repulsive in nature. Let us compare the answer and check that which one is the correct answer to it. Yes. So, answer is option number 3, which is repulsive and equal to this much. So, these are not the correct answers, and definitely it is not going to be 0. In this question, it has been given that a light ray falls on a square glass slab as shown in the diagram. The refractive index of the glass, if total internal reflection is to occur at the vertical face, we have to find out. You can see in this diagram, we are required to find out the refractive index of this glass slab in such a way that at this phase the TIR or the total internal reflection has to take place. Let us take an example. The light ray is incident on this face and this is the angle of refraction. If this is the angle of refraction and here I am going to draw a normal here. So, this angle is 90 degree minus R. Let us assume that this 90 degree minus R is nothing but it is the critical angle. If the angle of incidence at this face is going to be more than this critical angle, then definitely total internal reflection is going to take place at this phase. So, that means we can use Snell's law at this phase first, and we are going to write here 1 into sine 45 degree because the refractive index of air is 1. and at this phase it is mu time of sin r. So this is 1 by root 2 and this is mu time of sin r, and we can write sin r is equal to 1 by root 2 time of mu. So this is our equation number 1, and this result is going to help us to in finding out the further solution. So at this phase we can see here that if this is the critical angle, then we can write down the critical angle is nothing but it is 90 degree minus r. So we can write here sin critical is equal to sin 90 degree minus r, then only the slight ray is going to pass in this manner, and if you are going to increase the angle more than 90 minus r, then this is going to perform total internal reflection. So sin 90 degree minus r is equal to cos time of r, and you know that sin c can be written as 1 by mu is equal to cos r. And how this result is going to help us to find out cos r? You know that cos theta is nothing but it is square root of 1 minus sin square theta. So which can be written as square root of 1 minus sin square r. In the next set we can take this result and calculate it. 1 by mu is equal to square root of 1 minus sin square r, and you have already calculated the value of sin r as 1 by root 2 mu. So we can write here it is 1 by root 2 mu whole square. I recommend all the students to square both the sides at this point only in order to avoid the complexity of the calculation. So we can write here it is 1 by mu square is equal to 1 minus 1 by root 2 mu whole square, which is again 1 minus 1 by 2 mu square. On further simplification we can do here 1 by mu square is equal to 2 mu square minus 1 divided by 2 mu square, and we can write here 2 is equal to 2 mu square minus 1, 2 mu square is equal to 3, mu square is equal to 3 by 2, and taking the square root from both the side we can get the value that mu is equal to root 3 by 2. And let's check the answer. Options. So this is the correct answer to our question, that is mu should be equal to root 3 by 2, so that the total internal reflection is going to take place at the vertical face. In this question it has been given that in Young's double slit experiment the separation between the slit is 0.15 millimeter. In the experiment a source of light of wavelength 589 nanometer is used and the interference pattern is observed on a screen kept 1.5 meter away. The separation between the successive bright fringes on the screen we are required to find out. So for that I am drawing a small diagram of YDAC experiment, and you can see that this is called as slit width, that is small d, this one is capital D, and this is the light rays which is having a wavelength of lambda. When it is going to fall on the screen, then the patterns are going to be observed. So this is the central bright fringe, and you will be finding the first dark fringe here in both the side, and here it is going to be second bright fringe, second bright fringe. Now the distance between the consecutive bright fringe or the dark fringe is, how can you find out the consecutive the distance between the consecutive dark fringe or the bright fringe? Then that is nothing but it is the fringe width, that is called as your fringe width, and this fringe width is written as beta, that is lambda capital D divided by small d. So this is your beta. So any consecutive bright fringes or any consecutive dark fringes are having a difference here, that is equal to lambda capital D by small d. So we have already given the value, and we have to convert this nanometer, millimeter into meter first to get the answer. So we can write down that beta is, lambda is 589, so 589 into 10 to the power minus 9, capital D is the difference between the, here small d has been between the slits is 0.15 millimeter, and capital D is 1.5. Very carefully we have to write down. So this is 1.5 divided by 0.15 into 10 to the power minus 3. So I have converted all these things into meter first so that we can get the answer, and we can clearly see that this and this are going to be cancelled out and somehow, and finally just without doing the calculation you can find out the answer. So this is not the correct answer, this is not the correct answer, this is definitely not the correct answer, but I will do the answers now. So this is 589 into 10 to the power minus 9 into 15 into 10 to the power minus 1 divided by, because this is the way how you can overcome the mistakes. So this is 15 into 10 to the power minus 2 into 10 to the power minus 3. Now this 15 and this 15 are getting cancelled out, and finally we are getting the value as 589 multiplied with minus 9 minus 1 is minus 10, and this is minus 5, it will go up and it will make it as 10 to the power minus 5 meter. But the answer has been given to us in the form of millimeter, and you know that this can be broken like this: 589 into 10 to the power minus 2 into 10 to the power minus 3 meter. Well, so 589 divided by 100 is going to give us 5.89 into 10 to the power minus 3 will give you, if you remove this, it is going to give you millimeter. So the answer is option number 3, which is the correct answer to the question. In this question, this is a logic gate and it is very expected every year in all the papers. So in this question, we have given a logic gate and we have to write the truth table for the logic gate. This is a combination of many gates. Here it is a OR gate and a AND gate, and we are required to find out this is A and B, and this input is A, and you know that this is A plus B, and when it is coming out, so let this A plus B is C here. So here the Y is nothing, it is A dot C bar. So first of all, we have to make a table in such a way so that we can match this column to find out the answer. So here in the next set, so here it is A, this one is C, and C is A plus B, and Y is equal to A. This is an AND gate, so it is A dot C and bar. Whatever be the output is coming as Y, that one is getting NOT, is passed through a NOT gate to give us the answer. So first of all, we are going to write here as A, B, then it is going to be C, and C is your A plus B, and here it is A dot C, and again it is A dot C bar, which is your Y. Well, so what the combinations are possible here? This is 0, 0, 0, 1, 1, 0 and 1, 1. And you know that C is A plus B. So 0 plus 0 is 0. This is 1. This one is 1. And this is again 1. If you are doing it as OR. So A dot C. That means A is 0 and C is 0. We are doing the dot 1. So 0. 0 and 1. 0 and 1 is going to give us 0. 1 and 1. 1 dot 1 will be 1 and 1 dot 1 will be 1. Now you have to NOT it, that means reverse the values that we got. So here it is 1, 1, 0, 0. So these are the outputs and this is the input. Let's compare it with the options that has been given to us. For 0, 0, 1, 1, we should get 1, 1, 0, 0. Option number 1, 0, 0, 0, 1, 1, 0, 1, 1. So it is not the correct answer. Coming to the third one, because that was the second one, we will check it later. It is 0, 0, 0, 1, 1, 0, 1, 0, 1, 1. So this is again not the correct answer because the answer is coming as 1, 0, 0, 0. We are supposed to get it as 1, 1, 0, 0. So here it is the correct answer 0, 0, 0, 1, 1, 0, 1, 1. We are getting the answer as 1, 1 and 0, 0. This is the correct answer to our question. So option number 2 is the correct answer. Thank you for watching us. Stay tuned for more updates.